Assalamualaikum warahmatullahi wabarakatuh. I bid to my respected lecturer, Associate Professor Technologist Dr. Hairil ZAQWAN. So today, I would like to present about our project, Pressure Monitoring with Buzzer Alarm. First of all, my name is AFIQAH and my group member is Hairil, Asyraaf, ALMUAZZIM and ARIFF ZAQWAN. First with the introduction. So in the oil and gas industry, instrumentation and control system are the absolute backbone of the operation. They are very vital for maintaining safe, stable and efficient industrial processes by continuously monitoring critical parameters, especially pressure. So this is very crucial because unmanaged pressure is a massive hazard. If they are left unchecked, it can lead to catastrophic system failures such as pipeline rupture or severe equipment damage. So in the large-scale industrial setup, the real-time data is typically collected via specialized sensor and integrated into complex SCADA system for immediate feedback and action. However, understanding and testing this massive framework doesn't always require industrial scale budget. That brings us to our project. This project stimulates those large-scale industrial safety framework through a cost-effective Arduino-based prototype equipped with a buzzer alarm. By continuously monitoring pressure and triggering an alert if thresholds are exceeded, our system aims to deliver precise data acquisition, rapid automated response and valuable predictive maintenance insight. So, to guide the development of this prototype, we established 4 core objectives, which you can say that our first objective is our primary goal was to design a functional pressure monitoring system using an Arduino microcontroller as our core processor. Second, we aim to build an automated safety response, specifically to activate a buzzer alarm that the exact moment the monitored pressure exceeds a predetermined set limit. Third, the system must provide immediate visibility. We designed it to measure and display real-time pressure value continuously so operator can see shift as they happen. And finally, our overarching objective was to prove that the industrial grade concept can be modeled accessibly. We set up to develop a simple and cost-effective safety system that mirror the real-world safety logic without the extreme cost of commercial infrastructure.
Hello, my name is Hairil. I will talk about the problem statement and proposed solution. First thing first, it was about problem statement. Proper pressure monitoring system is often implemented, high cost and complexity. And lastly, does not equip with early warning system. Operator may not respond quickly to abnormal pressure condition. Secondly, proposed solution is about to propose the solution if the problem statement. A low-cost Arduino-based prototype to address the lack of affordable pressure monitoring in small-scale system. The system serves as a scalable alternative to expensive industrial-grade SCADA framework. It utilizes an Arduino Uno as a central processing unit to interface with the pressure transducer, providing real-time data acquisition and an automated audible alert system. Assalamualaikum warahmatullahi wabarakatuh. My name is Hairil. Today we will talk about research and planning. First is about the application. Primarily designed as a simulation for oil and gas industry safety such as water distribution network. It's pinpointing issue across dense network where attention monitoring is too costly. Second, hydraulic system, ensuring fluid flow regulation remains within safe operation limit. Third is pipeline, preventing catastrophic failures such as rupture or equipment damage. Next is about the methodology. We have 3 components, that is system component, system functionality and programming highlight. I will first talk about system component. It's about Arduino Uno, central processor, pressure sensor, detect pressure change, buzzer and LED, provide alarm and alerts. And lastly, LCD display. It's about display system status. Next is about system functionality. First, input. Pressure sensor converts physical pressure into electrical signals. Second, processing. Arduino processes these signals to determine if the pressure is within safe threshold. Third, output. Real-time values are shown on an LCD display and a buzzer alarm is triggered if the predefined safety limits is exceeded. The final one is a programming highlight. Signal processing. Detect threshold breach and alert mechanism trigger alarm for tampering. That's all from me. Thank you.
Assalamualaikum and good day everyone. Next for this slide, show the main component used in our pressure monitoring system. First, the LCD is used to display the pressure reading and system status in real life time, allowing user to easily monitoring the process. Next, the buzzer function as an alarm system and produce an audible alert whenever the pressure exceeds the preset safety limits. Then, the pressure sensor is responsible for detecting the pressure of the fluid or gas and converting it into an electrical signal system that can be processed by the system. Lastly, for the Adriano UNO, actually as the central processing unit, it receives the data from the pressure sensor, process the information and control both of the LCD display and buzzer whenever it pass the limit safety. Next, the design and assembly basic hardware setup. This slide shows the supporting hardware used in the assembly process. So first, the breadboard provide a temporary platform for connecting and testing the electronic component without soldering. It helps integrate the pressure sensor, LCD display, buzzer and Adriano UNO. Next, for the wires are used to establish the electrical connection between all components, ensuring proper signal transmission and power distribution throughout the system. These components form the basic hardware setup required for the operation of the pressure monitoring system of the project. Next, for design and assembly, final prototype. This slide shows the completed assembly of our pressure monitoring system. So on the left picture, we can see that the wiring connection between the Adriano UNO, pressure sensor, LCD display and buzzer alarms. So on the right is the final prototype mounted on a display board. The pressure sensor continuously measure pressure value and send it the data to the Adriano UNO. The Adriano process the data and display the pressure reading on the LCD screen. So if the pressure exceeds the predefined limit, the buzzer is activated to alert the user immediately. So this design provide a simple and low cost and effective pressure monitoring solution for the industry and educational application. Thank you.
Our testing process focus on 3 key steps. First, calibration, making sure the sensor reads physical force accurately on the screen. Second, threshold verification. We gradually increase the pressure to ensure the buzzer triggers exactly at the safe limit. And finally, stability, monitoring the system over time to guarantee consistent, lag-free performance.
Assalamualaikum. Today we will present our demo project, which is pressure monitoring with buzzer alarm. So first thing first, we are going to see our instrument, and so here we can see we have a circuit board. Next is display. Next is Arduino, and the main thing is pressure sensor. So here we are going to demonstrate our project. And now let's start. So we are already set the pressure, which is now is low pressure, which is between under 10 psi. And now we are going to put some pressure. Now is normal, and if the pressure sensor limit 40 psi, it will trigger.
Now, to be realistic, this is still a prototype, so it has some limitation. Because it's built on Arduino Uno, it just doesn't have the processing speed of a high-end industrial PLC. Also, because we are using a standard breadboard and jumper wires, is pretty sensitive to the environment. Harsh condition or interference could easily disrupt it. To scale this up for the real world, we definitely need tougher housing and industrial grade sensors. In conclusion, this project successfully demonstrates a reliable, low-cost way to boost industrial safety. By combining real-time data with an early warning buzzer, we have simulated complex SCADA function at a fraction of the price. Ultimately, this prototype proved that open-source hardware can effectively bridge the gap in safety monitoring for budget-constrained environments. Thank you.